In this video I'm going to describe how to make a box and whisker plot, which is another simple way to graphically represent a data set that's made up of a lot of continuous data points like this. So this is the data set that we looked at for the histograms of the trees in a different video, but here I'm going to use it to make a box and whisker plot. So this is just a simple graphical representation of a continuous data set. It's got lots of different quantitative data points. Alright, so here we go. So I've ranked these in order. So there are 31. So let's just do what we already know how to do. So n is 31. We've got 31 data points, and we can work out the average. So that's the sum of x all over n, and if we add it all up, then that's 2331.6 over 31, or 75.2 feet. So keep my units going here. We can work out the median. So let's do that. So we've got 31, so that's an odd number, that's good. So the one that's in the middle is the 16th. So there are 15 measurements on either side. So there she is, the median there, with 15, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 taller trees and 15 shorter trees. That's 72 feet. Okay, and the range is the tallest minus the shortest, that's 88 minus 60.5, or 27.5 feet. So that's already not too bad as a description of the dataset, but we're going to do one better. So what we're going to do is make quartiles. So that means divide the dataset into 4 chunks based on their rank, and we're going to use those to draw a graph. So how do we do? So first of all, we divide the data set into quartiles. So the rule is that the median, here we've got an odd number, so the median goes in both halves. So if we've divided it in half by the median, so we've got doing sections of 8. So each of these quarters have 8 measurements in them, in this case. So these are 4 sets with equal number of measurements. And here we're going to work out the so we call these the interquartile boundaries. And seeing as these are even numbers, we're going to do the same as we would for the median, and we're going to work out the average of the 2 on either side of the boundary. So here that gives us 71.05 feet, and here gives us 79.6 feet. Okay, so we've got this divided into 4 chunks. And I'm just going to write on here so you remember that you because n is an odd number. Okay, so we've got the divided data set into 4 quartiles with equal number of measurements. And then we're going to draw what we call a box and whisker plot. So the interquartile boundaries IQB, define the box boundary. So let's start drawing it here. So we can do this horizontally or vertically, but it suits me better to do it horizontally here. So we need a line, and I'm going to mark on there the median of 76 feet. Let's do that in green so you know what's going on. There we go. Then we're going to do the interquartile boundaries. So these guys, I've got 71.05 like that. And then 79.6 over here. And then we're going to draw a box using those. So like this. And then we're going to use the extreme values at either end to draw what we call a whisker. This is a way of defining the entire range of the whole data set. And I should write here that line shows the median. Okay, so let's do the extremes. That's 60.5 all the way down here, and 88 up here. Then I draw a line like that. We should have been going nicely into the middle, oops, of the box. Let's do that neatly. So that's the simple box and whisker plot. So this is kind of the central values, and this shows the extreme values, the entire range of the whole data set.